In this video, we will be discussing net positive suction head. Actually, we will be dealing with two net positive suction heads. The first one is the net positive suction head required. This is the minimum head required at the pump suction as determined by the manufacturer in order to pump liquid. Net positive suction head required is determined by pump design. The second net positive suction head is net positive suction head available. It is the actual head available at the pump suction as determined by process conditions. The net positive suction head required is the minimum pressure expressed in meters of head required at the suction of the pump for the pump to pump properly. Pump manufacturers determine the net positive suction head required by testing the pump under various conditions. It should be noted that the net positive suction head required is determined by pump design and does not include the vapor pressure of any liquid to be pumped. Vapor pressure must be converted to equivalent head, then added to the net positive suction head required to determine the pump's minimum suction head requirements. To calculate the minimum required suction head, you must first convert vapor pressure in kPa to equivalent head. Equivalent vapor pressure head in meters equals vapor pressure in kPa divided by the product of the relative density times G. You then add the equivalent vapor pressure head in meters to the net positive suction head required to get the minimum required suction head to pump liquid in your particular process. Example 3. A pump has a net positive suction head required of 6 meters and it is to pump water at 60 degrees C. What is the minimum required suction head? Example 3. Step 1. Finding the vapor pressure and relative density of the water. From the steam tables at 60 degrees C, vapor pressure is 19.94 kPa absolute and the specific volume of the water is 1.0172. Using the specific volume of the water, we find the relative density to be 0.983. Step 2. Changing vapor pressure to equivalent head. Vapor pressure equivalent head in meters equals the vapor pressure in kPa divided by the product of G times the relative density. Vapor pressure equivalent head equals 19.94 kPa divided by the product of 9.81 meters per second squared times 0.983. Vapor pressure equivalent head equals 2.07 meters. Step 3. Finding the minimum required suction head. The minimum required suction head equals the vapor pressure equivalent head plus the net positive suction head required. Minimum required suction head equals 2.07 meters plus 6.0 meters. Minimum required suction head equals 8.07 meters. The net positive suction head available is the actual pressure that'll be at the pump suction under operating conditions, expressed in meters of head. The net positive suction head available can be determined by the following formulas. For a suction head scenario, net positive suction head available equals the sum of static suction head plus suction pressure head plus suction velocity head minus suction friction head. For a suction lift scenario, net positive suction head available equals suction pressure head plus suction velocity head minus the sum of static suction lift plus suction friction head. The net positive suction head available must equal or be greater than the minimum required suction head obtained by adding the equivalent vapor pressure head to the net positive suction head required for the pump to pump. Both net positive suction head available and the minimum required suction head can be converted to equivalent pressure. Equivalent pressure in kPa for the net positive suction head available equals the net positive suction head available in meters times G times relative density. The pressure equivalent in kPa of minimum required suction head equals the minimum required suction head in meters times G times relative density. Example 4. A pump is pumping a liquid that has a relative density of 1.078 and a vapor pressure of 320 kPa absolute. The net positive suction head required is 6 meters. What is the minimum operating pressure required at the pump suction? Example 4. Step 1. We're going to change vapor pressure in kPa to equivalent head vapor pressure in meters. Equivalent head vapor pressure in meters equals the vapor pressure in kPa divided by the sum of G times the relative density. Equivalent head vapor pressure equals 320 kPa divided by the sum of 9.81 meters per second squared times 1.078. The equivalent head of the vapor pressure is 30.26 meters. Step 2. Find the minimum required suction head. The minimum required suction head equals the equivalent head of the vapor pressure plus the net positive suction head required. Minimum required suction head equals 30.26 meters plus 6 meters. The minimum required suction head is 36.26 meters. Step 3. Changing minimum required suction head to minimum required suction pressure. Minimum required suction pressure in kPa equals the minimum required suction head in meters times G times the relative density. Minimum required suction pressure in kPa equals 36.26 meters times 9.81 meters per second squared times 1.078. Minimum required suction pressure is 320 kPa for that pumping system. Example 5. A vacuum condenser has an absolute pressure of 40 kPa. The temperature of the liquid in the condenser is 60 degrees C. If the pump is to be located 6.2 meters below the condenser level, what must the net positive suction head required be for the pump to pump the condensate? Suction velocity head is 1.5 meters and suction friction head is 2.8 meters. For example 5, if we draw the system out, we see we have 60 degrees condensate with an absolute pressure of 40 kPa exerted on it in the vessel. We also have the liquid level 6.2 meters above the pump suction, so that would give us a static suction head of 6.2 meters. Step 1. Finding the vapor pressure and relative density. From steam tables at 60 degrees C, the vapor pressure is 19.9 0.94 kPa, and the specific volume of the condensate is 1.0172. Using the specific volume of the condensate, we find the relative density is 0.983. Step 2. Changing vessel pressure in kPa to head in meters. Suction pressure head in meters equals the vessel pressure in kPa divided by the product of G times the relative density. Suction pressure head in meters equals 40 kPa divided by 9.81 meters per second squared times 0.983, so the suction pressure head is 4.15 meters. Step 3. Finding the net positive head available. For a suction head scenario, net positive suction head available equals static suction head plus suction vessel pressure head plus suction velocity head minus suction friction head. Net positive suction head available equals 6.2 meters plus 4.15 meters plus 1.5 meters minus 2.8 meters. Net positive suction head available is 9.05 meters. Step 4. Changing vapor pressure to equivalent head. Vapor pressure equivalent head in meters equals the vapor pressure in kPa divided by the product of G times the relative density. Vapor pressure equivalent head equals 19.94 kPa divided by the product of G times 0.988. Vapor pressure equivalent head in meters is 2.07 meters. Step 5. Finding the net positive suction head required. For the pump to pump, minimum suction pressure required has to at least equal the net positive suction head available. Therefore, the minimum suction head required is 9.05 meters. Minimum suction head required equals the equivalent head vapor pressure plus the net positive suction head required. So, we know the minimum suction pressure required is 9.05 meters, and we know that the equivalent vapor pressure head is 2.07 meters. We can find the net positive suction head required. Net positive suction head required is 6.98 meters.